Hello students! Today we are going to talk about slope. Now basically the slope of a line is a way to measure how steep it is, but more specifically when we talk about slope is given by the rise over the run. The rise is how much the line is moving upwards, and the run is how much the line is moving horizontally. The best way to understand this is to look at an example. So let's take a look at a line and calculate its slope. All right, so here is a line. We want to figure out the slope. What we need to do is we need to pick 2 points on that line. So what I'm going to do is I'm going to pick this point right here, and then I'm going to pick this point. Basically, it's going to be easiest if we pick points that fit on the grid lines. So I wouldn't want to pick this point because I'm not quite sure how far up or down it is. But this point is nice because it looks like it's the point 3, 1. So we can get an idea of kind of where we are here. Now what we can do is to figure out the rise and the run, we can draw 2 little sides to make a triangle, and the rise is going to be how far we're moving up between those points, and the run is going to be how far over we move. So the rise here is going to be 2 because we go up 2 squares, and the run, because we go over 3, is going to be 3. So the slope here, the slope is going to be rise over run. The rise was 2, the run was 3. So the slope for this line is going to end up being 2/3. Now, you might not have chosen these 2 points. You might have chosen some other points. So let's do another calculation, but this time let's pick different points. Here I'm going to pick this point right there, and then also this point all the way down here. And I'm going to do the same kind of thing. I'm going to draw a triangle, a right triangle, by putting in a horizontal line and a vertical line, and that helps us see what the rise and the run are going to be. Now let's calculate the rise. We're going to go up 1, 2, 3, 4, 5, 6 squares. So the rise is going to be 6 here. Uh-oh, that's different from the rise before. But let's see what happens. The run, 1, 2, 3, 4, 5, 6, 7, 8, 9, is going to be 9 squares. So now if we recalculate the slope, the rise is 6, the run is 9, which looks different from our answer before. However, if we reduce this fraction, 6/9 reduces to 2/3, and we end up with the same answer. So it doesn't actually matter which points you pick, you should get the same slope, and that's because a line has the same steepness no matter where we're looking. So it doesn't matter which kind of range we're looking at here, we're going to end up with the same answer. Now, we don't want to have to use a graph and a triangle every time we want to calculate the slope. Life is easier if we have just a quick formula to do that. And so there is a nice formula that allows us to do that. And I'm going to demonstrate where this formula comes from. So first, I'm going to give you the formula. The slope, which we usually use the letter M to represent. I heard that comes from French, for the French word for mountain starts with the letter M. Doesn't really matter. The slope is given by y2 minus y1 over x2 minus x1. Now, what does that mean? Well, I am going to show you where this formula comes from. So what I'm going to do is I'm going to draw an xy plane down here. I'm not going to draw a very elaborate one because we don't actually want accuracy here. what I'm going to do is I'm going to pick a generic set of points. And these 2 points are going to be the points that our line goes through. Now, I don't want to give these points actual numbers for coordinates, because then that would mean these are specific points and not general points. So what I'm going to do is I'm going to give these points variables for coordinates. Now, this is going to be our first point. I'm going to give the coordinates, I'm going to represent them x1 and y1, and I'm going to represent the other one x2 and y2. Now, you may not have seen subscripts before. Those are little numbers in variables. But this is just a way to make it so that our variables are labeled in a way that makes sense. This is the x coordinate of the first point. This is the y coordinate of the first point. This is the x coordinate of the second point and the y coordinate of the second point. Okay? So now that we have these, we need to figure out the rise and the run. Now, to do that, we're going to have to draw a triangle, very similarly to how we did it in the problems before, a right triangle. And we're going to need to figure out the rise and the run, and to do that, we're going to need to know the coordinates of this point up here. Now, we don't want to call them x3 and y3, because what we want to know is what are these coordinates in terms of the coordinates that we've started with. Now, I want to look at the x coordinate here. The x coordinate is how far along the x-axis we move to get to this point. But I want you to notice it's the same as the x coordinate of this point, because both of these points are at the same place on the x-axis. Now, because this coordinate was x1, this is also going to have an x coordinate of x1. Now let's look at the y coordinate here. The y coordinate represents the height of this point. Well, which point has the same height as this one? That's going to be the one over here. Because these 2 points have the same height, they have the same y coordinate. So both of those will have a y coordinate of y2. All right, now we need to find the rise. The rise is going to be the difference in the heights between these 2 points. So that's going to be this height, y2, minus that height, y1. So the rise is going to be y2 minus y1. And that's where this comes in here. This is the rise. And then for the run, we need to figure out the difference in the x coordinates. That's how far apart these are. So we take this x coordinate, which is x2, minus the other x coordinate, which is x1, and that gives us our run. So these variables with subscripts, these actually represent the rise and the run given the starting points x1, y1, and x2, y2. This will allow us to figure out the slope of a line without having to go through the trouble of drawing it and then drawing a triangle and counting and make sure that we've counted correctly. Let's do one quick problem, and then you can get more practice with the worked out example problems. Let's calculate the slope of the line that contains 3, 4 and 7, -4. All right, this is our first point. So this is going to be our x1 and y1. This is our second point. So that's going to be our x2 and our y2. Now to calculate the slope, we've got y2 minus y1 over x2 minus x1. Let's plug these in. y2 is -4 minus y1, which is 4. x2 is 7 minus x1 is 3. -4 minus 4 is -8. 7 minus 3 is 4. and negative 8 divided by 4 is negative 2. So in this case, that line has slope negative 2. Now, what does it mean for a line to have negative slope? Well, our first example, this line had positive slope, and you'll notice it's going up from left to right. It's rising as we go from left to right. A line that has negative slope is going to be falling as we go from left to right. You'll get to see more examples of calculating the slopes of lines in the worked out example videos that are linked below.